So this question says that we have a diagram with a U tube. It shows a U-shaped tube with a cross-sectional area of A. That means that this area right there is A. Same thing over here, it's A. It's partially filled with oil of density rho. Okay, so I got rho in there. Put a solid cylinder which fits into the tube tightly but can slide without friction. And it's placed in the right arm. So we put a cylinder right there. And the system is in equilibrium. The weight of the cylinder is what? Well, there's a cool point right here. This point right there. Any of the levels, if I were to draw some point here, the pressure at that point and the pressure at that point are the same. If they're not the same, then the liquid's going to slide around. But same height in the same liquid is going to give us the same pressure. Which means this area right here, this line that I drew, is the same pressure. The bottom of the cylinder and the bottom of this column of water right here are going to provide this area with the same pressure. So I know that pressure is going to be the force per area. And since they have the same area, P1 is going to be force 1 over area 1. And in this side, the pressure from the cylinder is going to be the force of the cylinder over the same area, the area on the other side. So A2 and A1. And I know that these areas are the same. And I know that the pressures are the same, which means the force of the column from 1, so this downward force right there, has to be equal to the force due to the cylinder. Well, I want to know, this force of the cylinder is just the weight force of the cylinder, or just M of the cylinder times G. It wants me to have the weight of the cylinder, so I want this value. So all I have to do is I want to figure out what is the force acting on this area. Well, that's not too hard to do because I know that the mass of an object times G is going to be, if I know the mass of this column, I multiply it by G, it's going to just give me the weight force. And I know that the mass of this object, that object over there, can be rewritten as the density of the fluid times the volume of the fluid times G. Which, if I rewrite this, is going to be equal to the density of the fluid and the area that I get, or the volume that I get, is the area, the cross-sectional area, times the height, right? I'm just looking at this little cylinder right there. It's got an area and some height L. So its total volume is equal to L times A. So I substitute in the volume of this fluid is going to be A times L. My density of my fluid still tells me, when I multiply by the volume, it tells me my mass, and I get the value of G. So this value right here is equal to F1, which in turn is equal to the weight force. So when I look at this, I need the density of the fluid, the area of that column, the length of that column, and G. So I see choice A is the right answer, at least the way I have it, where I have the area, cross-sectional area, the height of this column, the density of that column, and G. And that will be equal to that cylinder, the force of the cylinder, the weight force of that cylinder. So this is a pretty common way of solving these problems where you have this constant pressure and you use the amount of liquid above it to determine how that pressure was produced.